Hey, and welcome to this video. Today, what we're going to do is start off with a new Ubuntu 22.04 installation, and we're going to install it fresh with ZFS and Ubuntu's inbuilt encryption of the volume that the installation is on. And I'm going to walk you through how to set up a USB that's read on boot that allows you to unlock the system, the encryption, using a key that's based on a USB stick that's plugged into the machine. So what I'm going to do is I'm going to illustrate it in a virtual machine, but this does work on bare metal machines. And it does work on 22.04.1. So I'm recording this video on December 28, 2022. If the guys at Ubuntu change something, then most likely, these instructions may continue to work, they may not, but as of now, they do. So I'm just going to walk you through somewhat quickly how to get this all set up. So we're going to install Ubuntu. I will be fast forwarding parts of the video that are really slow or that take time, just so we can get ahead with the guts of it. Okay, sorry to blow all of you guys away with that intro sound, but this is what you should see if you put in the Ubuntu installation media, whether it's on a USB stick or an optical drive or whatever, and then boot it up. You should get this screen. And we want to install Ubuntu. And I'm in Australia, so I'm just going to set it to Australian. Might increase the size of that there. Cool. For this video, I'm just going to go minimal installation because I don't want a huge one. It's just a demo machine that I'm creating for you guys and girls. It really wants to keep that window a different size, doesn't it? Cool. So we've got the installation type here. So what we're going to do for this video is we're going to select erase disk and install Ubuntu. And then we're going to go advanced features. We're going to select erase disk and use ZFS. And we're also going to check the box that says encrypt the new Ubuntu installation for security. So we'll go OK, and we'll go install now. this is where you select a security key, and this represents the passphrase that's used to encrypt the to unlock the volume initially. So you unlock it using a passphrase. So for this video, I'm just going to keep it really simple. I'm going to type, let's show it here. I'm going to type the key, the unlock phrase will be security. And that's for the encryption part. What you should do here is not make it, obviously it's a weak password, make it a very strong password, uppercase, lowercase letters, and punctuation, 15 plus characters. And then you should store that somewhere really secure, because if you're using the USB stick to unlock this computer, that's got the key on there, it'll be reliant on the device being present. You won't be typing in this phrase anymore. That being said, if your USB key breaks, or if you lose it, or you need to gain access to the installation some other way, your fallback will be this phrase. So it's important that you make it long and secure, and then you store it somewhere very secure, that other people can't get to it. I haven't tried this method with the recovery key section. My belief is that it will still work if you enable a recovery key. It will still work. However, I haven't tried it in any of my videos. I don't use a recovery key because in the process of setting this up, we're going to have two ways of unlocking the system anyway. So while I believe it will work, your mileage may vary if you enable this. We're just going to leave that blank. So we'll go install now. Now it will prompt us for the changes to the disks. We want to go continue. This is all inside a virtual machine, so it's not going to affect anything outside of that. Awesome. I'm in Brisbane. That's not where Brisbane is on the Australian map. It's more like here. So a little bit of trivia for you. And this is going to take a while. I might just fast forward this process because there's not much exciting stuff that happens between now and the end of the installation. But you guys have got the gist of what to do so far. Oh, actually, I'll just type this in and we'll go, my name is Bob. Bob LUKS demo is the computer name because I'm going to delete it anyway after this video. My username is Bob. And this is the actual login password. This is not a decryption password. This is just the login. So I'll make the login password login. So the decryption phrase is the word security, and the login password is the word login. Cool, and then I'll go continue. All right, I'm just going to fast forward the video because this part takes a little while. Okay, so after some time, the installation has completed, and I'm just going to go restart now. And it will eventually prompt me to eject the installation media because it's a virtual machine. It should automatically eject the ISO that I'm using to install Ubuntu. But on a bare metal machine, it will prompt you to pull out your USB or eject your optical disk. There we are. I'm just going to hit enter. Cool. So we'll do a reboot, and the first thing that will pop up with the new installation is the the decryption phrase that we set up. So as you know, the decryption phrase we set up is a word security. So I'm just going to go ahead and type that in. Cool. And that's been set up. Awesome. Now we're at the login screen, and the password that we use for the login is just login, the word login, if I can type. Awesome. And that should log us into a desktop. Great. I'm just going to skip all of this boilerplate stuff. Just bear with me. Awesome. So what we've got is a plain Ubuntu installation of 2204. We've unlocked the encryption using the passphrase for the decryption, and we've logged into the system using that other login password. What we're going to do now is we're going to prepare a USB stick that's going to hold our license file. So what I'm going to do is I'm going to physically plug in a USB stick on my host machine. I'm just going to map that to, oh, there we are. We'll do that later. And on a bare metal machine, this will just be plugging in a USB stick. Because I'm using a virtual machine just so I can show you everything in an easy way, I'm just going to map it here. So this is just emulating plugging in a stick. So I'm going to plug it in. The next step, all right, so it's got some old stuff on that stick. The next step is to open disks. So I'm going to hit the Windows key and type disks. I'm going to here. So that's the drive that we're going to put our decryption key on. This is the drive we're going to use so that if this USB is plugged into the computer when we boot up, it's going to use the decryption file off that drive. So what we're going to do is, I suppose, prepare that in the following way. So we'll go up to drive options. It's going to wipe everything on there. Just go format disk. And we want it to be quick, MBR, and we'll go format. Format again. Cool. So that's wiped it. Next up, we're going to put a partition on there. So if we hit the plus, leave that at maximum and go next. And I'm going to call this Linux -key, right? There's a few scripts and stuff we're going to go through in some following steps. The scripts will work if you call it Linux -key. If you do not call it Linux -key, you'll have to adjust the scripts a little bit. so that it picks up the right USB stick, because we're going to set it up in a way that when you boot it up, it's going to look for a USB stick with this name on it. And I'm just going to quickly make sure that I've named it right. Just bear with me a second. Yes, that is correct. So Linux-key, leave erase off. We want to select internal disk for use with Linux systems only, ext4. We don't want it used in Windows. And we're going to ensure that this is deselected. Do not check this box, because then you'll have password after password on as you're booting up, and that's outside the scope of this video. So just leave that turned off. So we're going to go create. Awesome. That is creating now. Great. So that took a little while to create. I think it's an old USB stick that I've mounted in here, but that is essentially ready to go. So if we navigate to Files, we should be able to see in the left-hand column Linux-key, and it should be empty, which is what we want. Cool. So we can exit out of there. Now, the next step is to actually create a decryption file. So unlike a passphrase, we want to create a file that is essentially passed into the decryption routine that allows for the decryption of the drive instead of a password. So how we do that is we'll start up terminal. So Windows key terminal. Cool. We get a terminal here. I'll maximize this for you. There we go. We're going to go to a root user, so sudo su, and log in. What is the password? Cool. And I'm just going to put stuff on the desktop, so cd desktop, just for now, so we can see things appearing. Cool. Next up, let's create a decryption key. So there's a number of articles that I use as a basis for this video, because I've actually been trying to achieve this kind of thing for about 6 months. I'm by no means a Linux expert. I'm just sharing this so that people that want to do this, or have like secure laptops, especially with a physical, essentially dongle, they can do it. But all of the other references that I'm referring to will be in the video description, just with an acknowledgement and a thank you, because without them, I wouldn't be able to get to this point. So to create the decryption key, we'll go dd if equals dev /urandom, bs equals 1, count equals 256, and then we want a greater than symbol, and then we want the name of the file. So again, you can call it whatever you want, but for the scripts to work just natively without having to change them, we're going to call it linux.key. Cool. So that's created the key. And if we have a look at the desktop, it is it's here, it is there. The woes of virtual machines, but yes, that has been created. So So that's great. So what we can do is we can take this and we can cut that, go into files, and we want to put it on the USB stick. Shouldn't be taking that long for 256 bytes. There we go. Wow, that took forever. Anyway, I'm just going to put that down to it being a virtual machine for the purposes of this video. So we can also navigate to the command line version of this by going cd media bob and then linux-key, linux-key, sorry, and we list that directory. We will see linux.key. So that's awesome. Next up, we need to configure our encrypted drive to work with this key, because at the moment it will only unlock with a passphrase. So for Ubuntu 22.04, if you installed it in the way that I've worked, the device that is encrypted is dev ZD0, but I'll just show you how to list your devices. So if you go BLK ID match token type equals crypto LUKS -o device. So that will give you two devices. If you've followed my steps, ZD0 is the device. SDA3 is it's a swap device that's been configured for some. I'm sure there's a reason for it. Again, I'm not a Linux expert. I just know it's not this device that we have to work on. It's ZD0. So now we'll configure the drive to be decrypted with this key that we've just generated. So we'll list out the directory. So that's the only thing on the USB drive. So let's associate it with decrypting the drive. So how we do that is crypt setup, LUKS add key. You got to pay attention to the capitalization there. Dev ZD0, and then linux.key, because that's essentially what we want to be. We want to be able to decrypt this device with that key. And if we hit enter any existing passphrase. So here is where you would enter the passphrase we set up. We provided in the setup for Ubuntu. So that was security, the word security. And it will take a moment. Awesome, cool. So the way that you can verify that it is set up properly is, I will show you the command for that. So we'll clear this out. So if we go crypt setup, then LUKS dump, then the device. So dev ZD0. It'll give you a whole bunch of information, but the two main things to look out for are the key slots. So key slot 0 represents the passphrase. So in our case, it's the word security, protecting the, like, being a decryption key for the drive. And then key slot 1 represents the key file that we just added, like just then. So if you see if you see two things in there, you're golden. If you are adapting this routine and you do have a recovery key, you might see 3 key slots, because a recovery key is most likely just going to add another one in a Ubuntu specific way. But again, that's outside the scope of this video. and I'm not quite sure how all that works. So we've got our 2 in there. That's great. We know that's fine. I'm just going to hit clear, and that's that part. All right. So the next step is to we have to change a script that mounts the encrypted drive on boot. And what we have to say to that script is, okay, let's not just unlock with a passphrase. Let's actually look for a USB drive that holds a decryption key as well. So what I'm going to do is I'm going to use a text editor called Vim. It's not installed because this is a new installation, so I'm just going to install it now. Cool. And you can use any text editor. This is just easier for me. But some people use Nano. You can probably use some like a text editor on the system. It's completely up to you. Awesome. Cool. So we'll clear that. Where we find this file to edit, so we go cd user share init ram fs tools scripts. Cool. If we list that directory, we should see that we've got a file down here called ZFS. That's the file that we're going to be editing in this step. So we'll go vim ZFS. So this is a huge file. Essentially, what we need to do is find a specific line in this file. Now, I'll give you the line number. What I'm going to search for is keystore dash. So it's right here. So the line number is 968, right? So what this line does is when the machine is booting up, this line is responsible for instructing the bootloader essentially to mount the encrypted drive and then ask for a passphrase. So what we're going to do is change this line because at the moment it's just going to ask for a passphrase. We want it to be a little smarter. We want it to look on a USB drive. So if you're using Vim, it's I for insert, and then we want to type in the following. So we want tries equals 10. So we want to try 10 times to either read a USB stick or read a plain text password from the user. And then we want to go key script equals scripts / USB unlock. And this will be a new script that we are going to create that tells essentially it will read this script and it will tell the bootloader what to do when we're loading up. So it's 968 key store $pool $ks none, then LUKS discard tries equals 10 key script equals script / USB unlock. All right, so I'm going to save that. I'm just going to escape :x, then enter. Cool. Now if we go back in, we can see that that has persisted. LUKS discard tries 10 key script. Cool. Next up, we want to actually create this file, USB unlock. So it's going to be a script. So we want to go vim USB-unlock. And it's important to realize as well that we're in user share init ram fs tools / scripts. In the bootloader, it will take this directory and map it to / scripts. So / will be the root directory and it will be scripts inside init ram fs itself. If you don't know what init ram fs is, it's essentially the area of the machine that loads the initial. Oh God, I don't even know how to describe this because I'm not a Linux expert. It's the first part of the machine that loads the rest of Ubuntu or the rest of everything. So it's kind of like a mini distro in itself. I think I've said that right. I'll probably get a bunch of wrong comments, but whatever. Cool. So we want to create this script. All right. So we've got a blank file. Now I will paste a link to my GitHub gist in the video description. I actually might just show it up here. Awesome. That's cool. That's cool. All right, so we'll maximize this. And we want gist.github.com and then me. And it's this one up here. It's called USB unlock. What this does is, in a nutshell, it will try and mount a USB stick that's called Linux-key. And then if it is able to mount it into the system successfully, it will try and read the unlock key file that we created earlier. So linux.key. And if it does find it, it will supply that key back to the routine that does the decryption, and then attempt to unlock the drive. And if it doesn't unlock the drive, it will try 3 times to use that key, and it will then fall back onto this, and it will say USB unlock key not found, please enter your password. So there's always a fallback if it goes wrong. So we'll copy this. Copy. All right, and we'll paste it in here. So I for insert, right click. Oh, that did not work. I'll have to go back. All right, let's have a look at our history. Wahoo. Right. Let's try this again. I'm not going to close the window that hastily. There we go. Paste. Huzzah! All right. So that's in here. So we've created a new file called USB-unlock. And then we're going to save this content to it. So escape, :x, and we should have that file. So if we go back in there, we can see that's persisted. And it's actually put nice, lovely colors everywhere, which is great. So :x, beautiful. What we also have to do with this file is we have to make it executable in the same way that ZFS is. So if we have a look at the directory again, we can see that there's some of the permissions that are different between the files. So the way we fix that is we go chmod 7. Whoop! Don't think the numpad's working now. Chmod 755 USB unlock. Cool. And now if we look at the directory listing, we can see that both of those permission sets are the same. Very cool. All right. So yeah, so that's the 2 main things are ensuring that that line is changed, USB-unlock, so scripts/USB unlock, and creating the same name file here. That's pretty essential. From there, the final step now is to update the bootloader or initramfs. And we do that with a single command. So the way we do that is update initramfs, and then we want a -u on there. We'll push enter. Awesome. So it will just go back to a regular bash prompt once that's done, and that's it. From now, we should be able to boot and decrypt our file system either using the passphrase or simply by having that USB stick plugged in into the system. So what we'll do is I'll reboot the system. Oh, well, why isn't that working? Hang on, I'll just do it through the menu. Restart. It's probably restart now instead of reboot now. Cool. So do we have that USB plugged in? Yes, we do. All right. So we'll go into Ubuntu 22.04. We'll just wait for it to do its thing. Cool. And you can see that crypt setup, key store up all set up successfully. That just means that it just read the license, the decryption key file off that USB stick. And that will continue to go to the log on screen. Cool. And I use that password of login. Awesome. Let's reset the screen size. Beautiful. And we're logged in. So I suppose the proof in the pudding is let's unplug this. So we're essentially taking that license USB out, the dongle we've just created, and let's restart the system again. Cool. So it says error, crypt setup failed, bad password or options. And then what it does is it falls back onto this. USB unlock key not found, please enter your password, right? And that fallback phrase that we used in the setup was security, the word security. I think I typed that wrong. Did I type it wrong? No, hang on. security. There we go. And it should log us, it should send us through to the login screen. Cool. And we can log in like normal. So just the word login, and we should be in. There we are. Cool. So that's essentially the gist of it. I hope this video helps. Some little notes. I've got this working on my bare metal machine and this virtual machine. I did a few demos on virtual machines before recording this video, and they were all met with success. That being said, this is a workaround. This is not sanctioned Ubuntu practice, I suppose, and there will be a number of people that do not sanction this practice at all. It's really important to note as well that this key here, I'll just mount it again. Here we are. Cool. So this key can now be used to decrypt this system. So you can if you can actually copy this onto another USB stick, and if someone knows enough about crypt setup and LUKS, they'll be able to use this key to decrypt your system. So it's really important that this key doesn't go anywhere. If someone gets a hold of this, your system will be able to be decrypted. So it's quite important that this doesn't go anywhere. There are a number of guides about how to obscurate the contents of this key, which are outside the scope of this video. But yes, this will decrypt your system. So if you've got mission critical information, if you've got political information that you're trying to, like, super secret information that you're trying to guard, then you need to ensure that this file and by extension um, the passphrase that you're using for the encryption of the system is absolutely paramount. That being said, if you just don't want your photos or whatever to go walk about, or your personal information, you can use this method for protecting your stuff too. And that's about it. I hope you enjoyed the video, and I hope you found it useful. I'll reference all of the people that helped me on this process to get to this point in the video description. I really thank those people, and the wonderful Stack Overflow community, the AskUbuntu community, and the Unix and Linux community in general. Thanks very much. Have a great day.